Hi everyone. Today we are going to study a topic which is related to linear algebra called eigenvalues and eigenvectors of a square matrix. It is very important when we are connecting to the real world. Eigenvalues and eigenvectors plays very important role. So first let us understand the definition of eigenvalues and eigenvectors. So the definition: given a square matrix A, if there exists a scalar lambda and a non-zero column matrix X such that Ax is equal to lambda X, then we say lambda is called the eigenvalue of a given matrix A and X is called an eigenvector of capital A corresponding to the obtained lambda. So we have a square matrix with a scalar multiplied to a square matrix, and we have a non-zero column matrix X such that the equation Ax is equal to lambda X satisfies, where lambda is called the eigenvalue and X is called the corresponding eigenvectors. So this is what the definition of eigenvalues and eigenvectors. So to obtain an eigenvalue and eigenvector for a square matrix, we have two methods. So first method is solving the matrix by using the characteristic equation. Characteristic equation of matrix A, which is obtained from this, that is determinant of A minus lambda I equal to 0. So this is the first method where this is solved theoretically. Fine. So we have method 2. This is method 1, where we use the concept called a Rayleigh's power method. So these are the two methods with which we can find the eigenvalues and eigenvectors. But when you're solving with eigenvalues by characteristic equation, you will get all eigenvalue and eigenvector. But when we apply the second method, that is Rayleigh powers method, you will get only the dominated, that is dominate eigenvalue only you will obtain. That is the largest eigenvalues obtained only in this method. This method is also called numerical way of finding the eigenvalues and eigenvectors. So let us start with the first method by using a 2 cross 2 basic matrix. So I'll take the first method by using characteristic equation. Okay. So I'll take a matrix. Let the matrix A be minus 1, 3, minus 2 and 4. So to find its eigenvalue, eigenvector, we are solving by using method 1. Okay. As I already stated, this method is used to find the eigenvalues and eigenvectors by characteristic equation. Okay. So we are applying the characteristic equation. Characteristic equation, that is determinant of A minus lambda I equal to 0. Okay. So A is the given matrix. Lambda is a scalar which is multiplied to identity matrix. Since our matrix is 2 cross 2, we will take I as 1, 0, 0, 1, identity matrix of order 2 cross 2. So we have determinant of A minus lambda I is equal to the matrix minus 1, minus 2, 3 and 4, which is matrix A, minus lambda multiplied with identity matrix. That gives minus 1, 3, minus 2 and 4. Multiply this lambda inside, so we get lambda 0, 0, lambda. We know matrix subtraction is element by element, so we get minus 1 minus lambda, 3 minus 0, minus 2 minus 0, 4 minus lambda. So now we are going to find its determinant by cross multiplying, taking the determinant of the diagonals minus the opponent diagonals. Okay, so A minus lambda I is equal to minus 1 minus lambda into 4 minus lambda minus 3 minus 0 into minus 2 minus 0. So we have minus 1 minus lambda, 4 minus lambda. Here we have 3 minus 2. So we get, carefully you have to multiply the terms. So we get minus 1 minus lambda into 4 minus lambda, minus of minus 3 into 2, 6 is equal to 0. Multiply these terms. So we get minus 4 into minus 1 into 4 is minus 1, minus of minus plus lambda, minus 4 into lambda is minus 4 lambda, minus of minus plus lambda square plus 6 is equal to 0. So the highest power is lambda square. I am taking it first. Next power is lambda. Here I have minus 4 lambda and here we have plus 1 lambda. So we get minus 3 lambda. Minus 4 plus 6. So we get positive 2 is equal to 0. So this is our quadratic equation for the matrix A minus lambda I. So we have a quadratic equation lambda square minus 3 lambda plus 2 is equal to 0, which can be solved by splitting of middle term. 2 lambda square can be written as minus 2 lambda minus 2 minus lambda. Minus of minus plus, 2 ones are 2, lambda and lambda becomes lambda square. When I add it, it is minus 2 minus 3, minus 2 minus 1 becomes minus 3 lambda. Substitute, take the common term. So we have got the factors as lambda 1 and lambda 2. This is nothing but the eigenvalues. So what we have to find after we get eigenvalues? We need to find its corresponding eigenvectors. So take a matrix A minus lambda I into x is equal to 0. Since it's a 2 cross 2 matrix, we will have two variables x and y. And 0 matrix has 0, 0 and 0 column. Now when you multiply the matrix A minus lambda into I, we get minus 1 minus lambda, 3 minus 2, 4 minus lambda into xy is equal to 0 and 0. Multiply the terms. Minus 1 minus lambda into x plus 3 into y is equal to 0. Minus 2 into x plus 4 minus y into y is equal to 0. So take this as equation 1. This equation will be used to find the eigenvectors. So case 1, let us take lambda is equal to 1, the first value, and substitute in equation 1. So when you substitute, you can see here minus 1 becomes minus 2x plus 3y equal to 0, and here it becomes minus 2x, again 3y is equal to 0. Any one equation you can take it. So we get minus 2x is equal to minus 3y, which implies 2x is equal to 3y. So x by 3 is equal to y by 2. Therefore, x1 denotes the eigenvector 3, 2 transpose. As I told, always the eigenvector should be in the column matrix. Okay. Now similarly we go for case 2. Take lambda is equal to 2 in equation 1. So we have minus 1 minus 2, so it becomes minus 3x plus minus 1 minus 2 is minus 3x plus 3y is equal to 0, and here it becomes similarly you go for the second equation, it's minus 2x plus 4 minus 2 is 2y is equal to 0. Take any one of the equation which gives the same result. Either you take the first one or second one. So I'll take the first one, 3x is equal to minus 3y. So your answer is x is equal to y, or we can write as x by 1 is equal to y by 1, which implies the second vector, that is x2 is equal to 1 comma 1 transpose. So let us conclude the entire result. The eigenvalues are lambda is equal to 1 and lambda is equal to 2. Corresponding eigenvectors are, actually we used to write capital X is equal to x1, x2. So x is equal to x1 values 3, 2 transpose. I will use column matrix, so it is 3 and 2. And x2 is 1 and 1 transpose, so it is 1 and 1. So this is the required eigenvalues and the eigenvectors. So in the next class we will be checking the numerical way of solving the eigenvalues and the eigenvectors. I hope the concept is clear. Thanks for watching. Meet you in the next video.